let's just talk about units for a minute. If you think of acceleration, velocity, and position, and you take an antiderivative of acceleration, what are you supposed to get? Velocity. So this would be velocity from A to B, which would be velocity at B minus velocity at A. You agree with that? Okay. Let's just say our units, we're using meters and seconds. Okay. So acceleration is would be like meters per second squared. Now dt is change in t, time. And so time is in what units? Seconds. So meters over second squared times seconds is meters per second. And that's why your velocity is in meters per second. All right. The antiderivative of velocity is position, which I'll use x. So this would be x of t evaluated from A to B, which would be x of B minus x of A. What kind of units would that be? Meters. Now, why are they meters? Because velocity is meters per second, time is seconds, meters per second times seconds is just meters. Now, what about position? The antiderivative of position, we don't really have an application of that, but this is meters and this is seconds, so when you take an antiderivative of that, whatever it is, the units are going to be meters seconds, like meters times seconds. Okay, so let's hold that idea. We're going to take that into average value. We've touched on average value already on some of the AP questions. That remember there was that like 1 over a number in front of an integral, and we're like, what is that? Okay, so if this is A, I'll put A right here, and I'm going to move B over here somewhere. I'm not going to use actual numbers. I'm just going to say A and B. We want his average Y value. Okay, so we define the average value of F. So average value is a Y value. Well, if you know the area under the curve, and you know how much you've moved on the base, how can you find the height? Just think of a rectangle. Let's say I form a rectangle here. If you know the area under the curve and you know this distance, how do you find this distance? Divide it. So how do you write the area under the curve? What's our symbolic notation for that? Integral from A to B. We're going to call this f of x. Okay, so then you divide that by the width of the x value. Okay, so how much is the x value? Without saying a number. B minus A? Okay, so average value. Now you will often see the number out front. Can you divide it underneath? Sure. That says B minus A right there. You will most likely see it out front of the integral sign. So, if f of x is a position function, and you computed the average value, so let's assume that that's a position function right there, and you computed the average value. So let's say you did the average value, so this would be 1 divided by time. I mean, I could make up numbers here. I'm just going to do a hypothetical. And this is position. So if you have a meter second position function and you computed the average value, what would you expect your units to be? If you want the average value of f of x. Why? Well, this is meters, seconds, divided by seconds. So it's 1 over seconds times meters seconds, which is going to give you meters. Because what this really asked you was for average position. Because we said f of x was position. So I asked you for average position. Well, if I ask you for average position, your units should be in position units. So say meters. Okay, example 1. Find the average value on this function without integrating. I gave you a piecewise function. You're not going to use that at all because I just gave you the graph. Okay, I was just telling you how I made the graph. So how do you find the average value from -1 to 3? I want his average y value. So take a guess. Where do you think his average y value is going to be? Do you think it's right here at 2? Is his average value 2 the whole time? No. Would you think it's 1? 1.5? Why do you think it's above 1? There's more up and down. Okay. So where are you guessing, Christian? 1.5? So this is Christian's guess right there. Okay, so how do you find it? Like if we want to be exact. So to find average value, you do the 1 over b minus a integral of area under the curve. So average value is 1 over b minus a. Your numbers are 3 and -1. So 3 minus -1, integral from -1 to 3. Does he have a name? Just call him f of x. Oh, he does have a name. So that's 1/4. Now, I don't want you computing this with equations. This all right here is the area under the curve. Get Joseph area. Area. Okay. So I know you like to ignore the word area. So what is the area from -1 to 3? 6, because that was the area under the curve. So then you'd get 3/2, which is 1.5. Good guess, Christian. Okay, so example 2, I didn't give you a graph. I said find the average value on the interval, except I want you to use antiderivatives now. So anytime you do average value, you need to see this word right here, average value, because that's the only reason you're putting a 1 over b minus a in front of your integral sign. Because I get kids who now put 1 over b minus a in front of every integral they ever do. No, it's only when you're doing average value. So what is this going to say right here? If this is your a and this is your b. E, because 2e minus e. Integral from e to 2e of 1 over x dx. What's the antiderivative of 1 over x? Who? What? Natural log of x from e to 2e. Okay, you cannot, that's not simplified enough. You need to plug the numbers in. So natural log of 2e minus the natural log of e. On the test tomorrow, I let you leave it like that if you felt good about that. What else could you do to this guy? You know what the natural log of e is? 1. You need to know that. Okay. So either of those two answers is acceptable. Okay, so what I have found is that we often now confuse average value and average rate of change, like they are synonymous. They are kind of synonymous. All right, so you have an oil tanker and he runs aground and it begins to spill oil. The number of gallons released by the tanker is given by this equation right here. What's the average rate flow of oil? that's worded funny. From 1 to 3 minutes. So this is a time interval, okay? Now, probably first thing you need to say to yourself is G a position, a velocity, or an acceleration? Why is it position, Garrett? Okay, so it's the number of gallons? But what is having the maximum? Left in the tanker? I agree. Left in by the tanker? Left in the tanker. Okay. All right, so what is the average rate flow of oil? So you're looking for the average velocity. How do you find average velocity from position? Okay, so you're going to do G2 minus G1 over, no, 3. That was not my fault, that was Garrett. He said 2. Over 3 minus 1? Okay, why aren't you doing an interval? Right? Go ahead, finish it off. Right. So we're not doing this. That's my question, is why are we not doing that? But this is average value also, an integral. Okay. I guess you could think about the units, right? What's the antiderivative of G? What kind of units does that give you? Gallons, minutes divided by minutes, which is back to gallons. So could you ever use an integral to find the average velocity? If you, and then, yes, that's exactly what that means. Okay, so that's my aha. So to find I'm just going to use velocity as the example. To find absolute velocity, average, see, this whole day, I just need to go home. To find average velocity, see, so it'd be V of B minus V of A over B minus A. That would be average velocity. Or you could do an integral.
Now late to class. Please report to your house office.
This may be the miracle error there. Ever. Miracle. I don't know that miracle is the right word. This may be the PTD. It's more like post-dessert depression. Okay, so did you see that I had velocity there? And that was supposed to be position, because change in position over change in time. All right, now, if you did an integral, what would your integrand need to be to make this be average velocity? Why? Okay, because when you integrate velocity, it's position. Now, do you remember on the first page, I had just this? And I said, what do you get? You said x of t from b to a, which is x of b minus x of a, which is x of b minus x of a over b minus a. Are you being facetious? Okay. How do you know which one to use? Which function you're given. If I give you the position function, use the one that gives you the position function. If I give you velocity, you would use that one. All right, so, or you could do that. But what if it's a really complicated derivative? Okay. All right, example 3. An elevator is being tested and travels from floor to floor without ever opening its door to pick up people. So it's a continuous although it does have to stop and move up and down floors, okay? But all right, this is for 60 seconds. The elevator's velocity is given in the table. The acceleration is in feet per second per second. The table shows values at selected times. So approximate this thing right here using a midpoint approximation, 2 subintervals, and explain the meaning. Okay, so this is like a little mini review for your test tomorrow. Okay. All right, now let's talk about writing this. Now remember this whole equaling everything out? We don't want to do that. So try not to put equals. You could do, that's not even safe. Let's just don't do anything. Okay, now are you going to keep the 1/40th out there? You want to go ahead and put that out there? Okay, I would say put it there because you might forget in the end to divide by 40 or to write it. All right, now we're going to do a midpoint approximation. 2 subintervals. So half of 60 is 30. I should pay attention. I should realize that it said 20 to 60. No. That's right. Please. 20 to 60. And the thing about last period, they're like the most unforgiving class. You know, they just walk out going, she doesn't know what she's doing. I was like, whereas like next period it'll be like, it's okay, Miss Pratt, we understand. It's all right. We all make mistakes. I'm just doing it very well today. Everybody makes mistakes. All right. 20 to 40 is 20. The middle of him would be at 30, so you pick up the 10. No. 40 to 60, middle of that would be 5. All right, do you want to compute this? 200 plus 100 is 300. 1/40th of 300. 30 over 4, 7.5. If you felt like, now on the test, obviously you probably wouldn't do that, right? You were going to leave it. All right, now it says explain the meaning. Okay, remember the 3 things that you want for the meaning. What is it, the units, and the time? Okay, so does anybody want to try this one?
Average velocity of feet per second for t equals 20 feet per 60 seconds.
The elevator, context of the problem, right? You didn't mention the elevator. Could be a rabbit. You got to be careful, right? So let's just start with the elevator. The elevator does what, Joseph? Okay. Well, I was going to accept the rest of your answer. I think you said averages.
said average velocity.
All right,
It averages 7.5.
7.5 feet per second from time equals 20 to time equals 60, and this was in seconds. No, because it's you did an approximation. I mean, it knows it's an approximation. If you don't write the units right here, what I have in green, then as long as you put them in your answer, your reason, or vice versa, that's fine.
Their average is 140th.
You could. That's okay. You don't have. You're okay. I need to put an exclamation question. Yep. All right. How would you estimate v prime of 22? V prime at 22 falls where? Right in here? Okay, so what two numbers should you use? 20 and 30? So v of 30 minus v of 20 over 30 minus 20. Need to put the numbers in there. 10 minus 5 over 10. No? I had the right 10 though. I don't even know that we needed that question. Okay, so I'm not going to really work out these last ones where it says keeping it straight. I'm just trying to, and maybe y'all are so advanced more than like what I see sometimes in the past, is whether or not you're putting the 1 over b minus a, whether or not you're doing slope, like what you're doing. So if you were to, if I just gave you this, not even area under the curve, if I just give you this, can you work it? Okay, so that was what the review sheet was about. All right, so I'm going to work pieces of it and then I'm just going to stop. So how do you take his antiderivative? Take it. 1/3 plus 2x squared from 0 to 3, right? Plug in, da-da-da-da-da. Okay? Okay, you get an answer of 27. I'll go ahead and tell you that. Well, at least that's what I got over the break. All right, the average rate of change from 0 to 3. Now look at B and C. One says the average rate of change, one says the average value. If you're stuck on what to do, just put some units in there and go from there. So if you don't like f of x, call him velocity, because you're much more familiar with velocity. So if you want the average rate of change of velocity, then that would equal what kind of idea? Rate of change, slope of velocity, which would be acceleration. Well, how do you get acceleration off of velocity? You would do, so you don't have an equation, but this is over 0 to 3. Okay, so this would be f of 3 minus f of 0 over 3 minus 0, yada, 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 yada. Which I did not work that one out. Okay. But what if you did average value of f of x? So again, if you like to think about it as velocity, the average value of velocity should be what kind of units? Or what kind of an answer? Average value of velocity is the average velocity. So you need velocity, but if you take a derivative of this, that's going to give you acceleration. So what should you do on this one? Take an integral, which is going to give you position, and then divide by time. So this would be 1/3 integral 0 to 3. Don't use velocity. Make sure you use what they gave you. That was just a substitute.